Now we've already done this example. We solved it manually. The graphs are here. Some of the solutions, like I said, this is done by hand. There's no graph paper, nothing. And so the best you can do is approximate the solution. We said the solutions are 1, 4.1, 1, negative 4.1, and the other solutions look like negative 1.8 and 2.5, and negative 1.8 and negative 2.5. The question is, what if I want to be more accurate? What if I want to find the actual solutions? What do I do then? Well, hopefully you are in possession of a graphing calculator. If you don't, it's not a problem. You can just go on the internet and use decimals. And using decimals, you can find points of intersection. So let's take a look. What do we do if we have a graphing calculator? We're going to start with the second equation here. It's easier to solve. We're going to add 15 to both sides. And so we have 5x plus 15 is equal to y squared. We're going to take the square root, and we're going to get that y is equal to square root of 5x plus 15, or y is equal to negative square root of 5x plus 15. We're going to take the top equation now. My first step is going to be to subtract 25x squared from both sides. So we have 4y squared is equal to negative 25x squared plus 100. My goal is to get the y by itself on one side. I'm going to divide by 4. Everything. And so I have y squared is equal to negative 25 over 4 x squared plus 100 over 4. Yes, I could simplify it. I'm going to take the square root now. I'm going to have y is equal to plus or minus. And this is how I'm going to enter it into my calculator. Parentheses, negative 25x squared plus 100, close parentheses, divided by 4. So we're going to have y is equal to that, to the positive square root, and then to the opposite of the same square root. So parentheses, 25x squared plus negative 25x squared plus 100 divided by 4. We're going to take all of them. We're going to turn the calculator on. We're going to go to y equals. And as you can see, I have entered all 4 equations. There they are. Once you enter the equation, a good idea is to go to your window. Put your window in standard form. That means your x's are between negative 10 and positive 10. So are your y's, and the scale is 1. And then press graph. And you have the graph of a parabola and the graph of an ellipse. How do you find the points of intersection? Use the trace button. So you go to about where they intersect. We can see that the x-coordinate is about 0.9 and the y-coordinate is about 4.4. What if you want to do this and you want to be more accurate? You press the zoom button. You go to zoom in, and then you zoom into that point. There's the graph of the parabola. Here comes the graph of the ellipse. You press the trace. Well, you wait a few seconds. Now you press the trace button. And you go to the point of intersection. It looks like it's about 0.9 and 4.4. If we look at other graphs on the board, we notice that the ellipse is and the parabola are both symmetric with respect to the x-axis. So then, once I found the point above the x-axis, I know the point below the x-axis, because both points will have the same x-coordinate, but the y-coordinates will be opposite of each other. So now we have one point, we have 0.9 and 4.4. 0.9, 4.4, and we said negative 0.9 and negative 4.4 is also a solution. We're going to now find the second point. You can do one of two things. Just go to zoom and zoom out. That's one thing that you could do. A second thing that you can do is just go to the window and set the window back to the original settings. So, trace. Notice that we're going to another point of intersection. Zoom in, press enter. There's the graph of the parabola. Now comes the graph of the ellipse. We're going to be patient just a few seconds. We're going to press trace and I go to the point of intersection. It looks like negative 1.7 and 2.5. And that's it. So negative 1.7, 2.5, and negative 1.7 and negative 2.5. And that's how you would use your graphing calculator to approximate the 4 points. And that's it. We're done.